Hi, this is Algebra 2, Lesson 46. We're going to talk about more on radical expressions and radical to fractional exponents. We're starting on page 203. We've been simplifying expressions such as, this is negative the square root of 2 over the square root of 3, plus 3 times the square root of 3 over 2. So we've been simplifying these by first using the quotient of the square roots theorem, so we can rewrite this as this negative square root of 2 over the square root of 3 equals 3 times the square root of 3 over the square root of 2. And then we're going to rationalize the denominator by using the denominator-numerator rule. So we're going to multiply this term by the square root of 3 over the square root of 3. And we're going to multiply this term by the square root of 2 over the square root of 2. And that gets rid of the radicals in the denominators because we do not like those. So that is going to give us, we have a negative here, we don't want to lose that. The square root of 3 times the square root of 2 is the square root of 6 over the square root of 3 times the square root of 3 is 3. Plus 3 times the square root of 3 times the square root of 2 is 3 times the square root of 6 over the square root of 2 times the square root of 2 is 2. Okay? Now we're going to find the common denominator and add the fractions, just like we've been using since about 4th grade. So this common denominator of 3 and 2 is 6. So we're going to multiply this term by 3 over 3. We're going to multiply this term by 2 over 2. And we will get minus 2 times the square root of 6 plus 9 times the square root of 6 all over 6. Okay, now we can add these top terms together and we will get 7 over the square root of 6 over 6. And that is going to be your answer. Okay, we've been doing these. Now we're going to see some more complicated ones. Yay! So, our first example is simplify 3 times the square root of 2 over 7 minus 5 times the square root of 7 over 2 plus 3 times the square root of 56. So we're going to rewrite these as 3 times the square root of 2 over the square root of 7 minus 5 times the square root of 7 over the square root of 2 plus 3 times the square root of 56. Okay, that just cleaned everything up a little bit. So we have this term, and let's see if we can simplify this. The roots of 56 include 2 times 28, and 28 can also be divided by 2, which means there's a 4 in here, and 4 is a square root, which is very nice. Or it's a square, rather. So if we can pull out a 4, it would be 4 times 14. So we can write 3 times the square root of 56 as 3 times the square root of 4 times the square root of 14. The square root of 4 is 2, so this is going to be 3 times 2 times the square root of 14. So that's 6 times the square root of 14. Okay? So we're going to replace 3 times the square root of 56 with 6 times the square root of 14, which just makes everything a little simpler in the end. Okay? You can do this later, but as long as it's here, we might as well do it now. So we have 3 times the square root of 2 over the square root of 7 minus 5 times the square root of 7 over the square root of 2 minus plus 6 times the square root of 14. Okay, now we're going to get rid of these radicals in the denominator. So we're going to multiply this one by the square root of 7 over the square root of 7. We're going to multiply this term by the square root of 2 times the square root of 2. And this one doesn't have anything in the denominator, so we don't have to worry about it. Okay, so now we have 3 times the square root of 14 over 7 minus 5 times the square root of 14 over 2 plus 6 times the square root of 14. So everything has the same radical in it. All the terms do, which is convenient. Okay, our lowest common multiple of the denominators is going to be 14. So if we multiply this one by 2 over 2, and this one by 7 over 7, and this one by 14 over 14, as ugly as that looks, then we'll have everything over one term. So 2 times 3 is 6 times the square root of 14. Minus 7 times 5 is 35 times the square root of 14. Plus 14 times 6 is, look ahead, or look back to where I've already figured this out once, 84 times the square root of 14, all over 14. Okay, now we can add these, the terms on the numerator together, and we will get 55 times the square root of 14 over 14. And that is as far as that can be simplified. Radicals to fractional exponents. When we have very complicated radicals, sometimes it helps to rewrite them as fractional exponents. So here we have simplified the square root of 3 times the square root of 3. That's pretty ugly. But if we rewrite it, we get 3 times 3 raised to the 1/2, all raised to the 1/2. Okay, now we can distribute this exponent to the inside. So 3 times 3 to the 1/2 power is going to be 3 to the 1/2 power. 3 to the 1/2 power raised to the 1/2 power is going to be 3 to the 1/4 power. Okay, now we figured this out by adding these. So here we were multiplying the exponents. This is actually 3 to the 1. So 1/2 times 1 is 3 to the 1/2. And 3 to 1/2 times 1/2 is 3 times 1/4. Okay? Now we're going to add these because these are just multiplied times each other. So it's going to be 3 times 1/2 plus 1/4. The common denominator here is 4. So this will be 2/4 plus 1/4. This is 3 to the 3/4. Whoop, that should be a 4. Okay? And that is as simplified as we need to get with these. Alright, let's try this one. We have the cubed root of 3 times the square root of 3. So if we rewrite this, we'll have 3, and this 3 is just to the 1, and times 3, and whoops, sorry, let me start over. We have 3 to the 1 times 3 to the 1/2, all raised to the 1/3. Okay? Because this guy is on the outside, we're raising these to a power. We're going to distribute by multiplying these exponents times this one. So that will give us 3 to the 1/3 times 3 1/2 times 1/3 is 1/6. Okay? Now we can add these together. 1/3 is the same as 2/6. So this is going to be the same as 2/6 plus 1/6. Which equals 3 to the 3/6, and then we can simplify this to 3 to the 1/2. Okay? let's try some using variables. So we have the square root of x cubed times y squared times the cubed root of xy. So this is going to be x cubed to the 1/2. This is going to be y squared to the 1/2. Here we have x to the 1/3. And here we have y to the 1/3. Okay? Now we can simplify these a little bit. X cubed times 1/2 is going to be x times x to the 3/2. Y squared, and the square root of that is just going to be y. It's going to be y 2 over 2, which is the same as y to the 1, which is the same as y. So this really cancels and becomes a 1. And then we have x to the 3rd and y to the 3rd. Now we can put our like terms together and add up our exponents. So we have x to the 3/2 and x to the 1/3, y to the 1, and y to the 1/3. So this is going to equal x to the 3/2 plus 1/3 times y to the 1 plus 1/3. So this least common multiple here in these denominators is 6. So this is going to be 9/6 plus 2/6, which equals 11/6. So this will be x to the 11/6. Here we've got thirds. This is going to be 3/3 plus 1/3. So this is going to be y to the 4/3. Okay? They're ugly, so just take your time and work with the fractions. You already know how to do the fractions. Okay, here we have the cubed root of x to the 5th, y to the 3rd, times the 4th root of x, y to the 5th. Okay? We're going to start by rewriting these into fractional exponents. So we'll have x to the 5th raised to the 1 over 3. We have y cubed and the cube root of that. We have x to the 1st power, the 4th root of that, and y to the 3rd. Can't read my handwriting. Sorry, 5th power raised to the 1/4. Sorry, these markers are supposed to be fine point, but I don't think they're fine point enough. That's a 5. And this is also a 5. Okay, so here we have x. 5 times 1/3 is 5/3. We have y. 3 times 1/3 is 3/3, which is going to cancel to a 1. We have x. 1 times 1/4 is 1/4. We have y, and 5 times 1/4 is 5/4. Okay, we're going to put the like terms together. So we have x to the 5/3 times x to the 1/4 times y to the 1 times y to the 5/4. Okay, the least common multiple of 3 and 4 is 12, so we're going to multiply this one by 4/4 and this one by 3/3. So here we will have 20/12, and here we will have 3/12. We're going to add those together and get x to the 23/12. Is that ugly enough for you? Here we have 1 and 5/4. 1 is the same as 4/4. So we can add 4/4 and 5/4 and get y to the 9/4. And that is ugly, but correct. Okay, try your practice problems in your homework. Let me know if you have any questions. Take your time and work through the fractions. Okay? Thank you very much.